Alrighty, earlier start today. Let's do it. It's also hard, so let's hopefully do it. Painting a grid with 3 different colors. You're given 2 integers m and n. Consider an m by n grid where each cell is initially white. You can paint each cell red, green, or blue. All cells must be painted. Return the number of ways to color the grid with no 2 adjacent cells having the same color. Since the answer may be very large, return modulo 10 to the 9th plus 7. Okay, so if it's a 1 by 1, given 2 integers, it's a 1 by 1. Okay, so basically there's 3 ways of coloring a 1 by 1 with no different cells, or, well, no two cells having, no 2 adjacent cells having the same color. So it's red, green, or blue. It's a 1 row, 2 column, and there's 6 ways there. And then if it's 5 rows, 5 columns, there's 580,000, 581,000 ways. Okay, I think this one is dynamic programming. I'm almost certain. Okay, I think it is anyways. Feels very similar to the last one that stumped me and continues to stump me. Okay, so let's try this. Let's say I'm going to rename this rows and columns because I prefer actual labels rather than letters. M and N are very closely spelled and appearance that it just is annoying to have to deal with and maybe make mistakes writing M versus N. Okay, anyways, so I have some number of rows and columns. And if I were to think about dynamic programming this, it's going to be it's going to try to relate like the n plus 1 case to the n case, or like if you have a sub answer, how does that relate to the answer plus 1? So if you have like 2 rows and 1 column, how does it relate to 3 rows and 1 column? Or 2 rows and 1 column, how does it relate to 2 rows and 2 columns? I think you sort of need to know, you probably need to know the number of ways to color up to a certain point, and also the last color that was used, so that the next cell is not the same color. But then there's a whole lot of adjacency. So if I were to visualize it, let's say I'm dealing with the 2 by 3, right? Actually, let's go ahead and do some examples. So test case, let's say it's a 2 by 3. I'm going to assume that the answer is 0. But the actual answer is, I don't know, so how many ways to color 2 by 3? 54 ways. That might be too much for me to try to come up with all 54 ways 2 by 2. 2 by 2. Before I look at the actual answer, let me predict it should be, so it should start red, green, or blue in the upper right corner. And then let's say it could be green here, or it could be red, blue. And then if it's red, green, the second row could be green, blue. The second row could be green, red. blue, green, blue, red. So any of those would work. And then if the first row was red, blue, then the second row could be green, 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 red. It can't be green, blue. Wait, this can't be. It can't be blue, green here. Green, red. It can't be green, green. It can't be red. So I think green is the only one there. So this could be blue, green here, or blue, red. So if red is the top right corner, I think there's 8 ways. So I'm going to guess there's 24 ways if you choose one of the other colors. Oh, actually, I'm miscounting. This is the first row, and these are all the second rows. So it's actually 6 ways of doing this. So therefore, if this is just based on red being the first color, then there's 3 ways of choosing something different than this. It's kind of symmetric. So that's like 3 times 6, which is 18 ways. Okay. I mean, that makes sense, but how to generalize that? Is it possible to generalize that? I don't know. So from here, if I know that there's 18 ways of generating a 2 by 2, is there some way of connecting it to like a 2 by 3? Okay, let's maybe even consider something simpler. So 1 by 1 is obviously 3 ways. I think any number that you get should be a multiple of 3, right? Because it's all symmetric. It's color symmetric. You can choose any of 3 colors as your starting color, and there should be some count of that. And so it's gonna be 3 times that count for the total total. Anyways, so 1 by 1 is 3. 1 by 2 is gonna be 6. And 1 by 2 is 3 for the first block and 2 available for the second block. Okay, and then 1 by 2 versus 2 for 1, 2 by 1 is going to be the same. And then 2 by 2, somehow that became 18. So there's 3 for the, so there's 6 for the 1 by, so 6 for the 1 by 2, right? And each of those 6 ways, so like green, green, red, red, blue, blue, green, red, red, green, green, blue, blue, green. Those 6 ways. No, shit. That's definitely not it. They need to be different in color. So green, red, green, green, red, green, blue. Red, blue, red, green. Blue, green, blue, red. So each of these 6 ways needs to come up with 3 ways of getting the second row. Yeah, so like red, green, there are 3 ways of getting the second row. But how would you relate that? how would you know that there's ways? So for a particular sequence of a row, you have some number of ways. For a particular sequence of a row, if you're just going by rows, you should have some number of ways of going in the second row. And then you can just do that for the n number of rows. Because the number of rows, because you can just generalize it and just ignore if you have a certain row as your last row, then the previous rows don't really matter in some sense. You just need to add one more row, and how many ways can you add another row? So, and you just need to generalize this. So what's going to happen? So for all the number of ways I can do a row with 2 elements, for any 2 elements that can be that row, how many ways can you form the next row below it? Apparently there's 3. Well, for the first letter in that row, first color, there's obviously going to be 2 ways. And then the second element, and of this 2, either it's going to match the second element in the row, in which case, so of 2, if it matches the second element, then there's only one other thing that you can do to follow. So if this is green red, below green red is either going to be something that's red or blue, and if it's green red and below it is red, then it cannot, no, so let's say if it's a blue, then this thing cannot be red, right? Otherwise there'd be 2 reds, so it has to be green. So of the 2 ways, one way has one option. So overall this is only one option. But then if you have a red underneath the green, then there's 2 options. The red can do green or the red can do blue. So overall, if this is the first row, then these are the 3 options. Okay. Is this generalizable? Yeah. Okay, if the first row is something that is 3 elements, so 1 by 3. 1 by 3, I'm going to say should have 3 for the first color, 2 for the second color, and then it branches from there. No. It's 3 for the first color, 3 for the second color, 2 for the second color, and then 2 for the third color. So it should be 3 times 2 times 2, which is 12. 1 row, 3 columns. Okay, yeah, so it is 12. So now the second row, below 322. Below this thing, there's 2 ways to do this one. Of those 2 ways, one of the ways would, of those two ways, one of them would be different than both these. If they're different than both these, then the next color has to be the first color in the first row. So it's 2 and then 1, and then it's either, and then if it's the other one, then it's, gosh, how do I explain this? It's 2 then 1. So let's arbitrarily say we're now that it's A, B, C as the three colors. So it's A, B, and below the A is either B or C. So let's say it's B. No, let's say it's C. So because this is C, you cannot have C here, and you cannot have B here. So it has to be A. So it could be CA, or it could be, again, BA or BC. Okay. Now let's consider a third element, ABC. So the third element here could be either ABC or ABA. So if the third element is ABC, then CA could be followed by B, or CA could be followed by C. So if C is followed by A, it can either be B or C. BA, what am I doing? I'm so stupid. It can't be CAC because then that would match this thing. So it has to be CAB. It has to be CAB. C can't be B here, can't be C here. BA can't be A here, can be B, cannot be C. So CAB. And then of the other two ways, BA could follow by, it can't be followed by C or an A, it needs to be followed by a B. And then BC, it can't be followed by, it can be followed by an A, cannot be followed by a B, cannot be followed by a C. Huh. So it actually formed no new ways? Really? So if you add C here, each of the three ways just extends out one. But if you add A here, CA could be, it can be B or C. CAC. And if it's ABA, then BA could be B or BAC. And if there's BC, then this cannot be A, cannot be C, it has to be B. So what is my guess here? My guess is that so there's three ways. So from a 1 to 1, so from 2 2 is 6 ways. And then 1, 3 is 6 ways, right? Yeah. And then a 2, 3. So each of the 6 ways. 1, 2 is 6 ways. Sorry, 1, 2 is 6 ways. A 2 by 2 is 18 ways. 1, 3 is 12 ways. Ow. 1, 3 is 12 ways. A, B, C, A, B, A. B, C, A, B, A. That could also be, it could also be A, C, B, and A, C, A. So that's four things that start with A times 3 things that could be replacing times 3 if A is replaced by B or C. So of those 4, I know that if it was just a 1 by 2, it would be 6. 1 by 3 would be 12. 2 by 2 would be 18. 2 by 2 would be 18. 1 by 2 would be 3. C, A, B. A, B, C. Easy as cab. If it's A, B, C, B, A, B. Man, I definitely lost my train of thought. So if it's the first 2, there's 6 ways to form something below that. And of those 6 ways, 6 ways? No, it's 3 ways. No, it's 2 ways. No, it's 3 ways. Is it 3 ways? It's 3 ways. Okay, there's 2 ways. No, there's 6 ways of forming the first 2. 6 ways of forming the first 2. And the 6 ways of forming the first 2 is either A, B, or AC, and then some symmetry based on that. A, B, or AC, which is 2 ways, symmetric with, which is going to be times 3. Hmm. If I had, let's say, a grid, if it's a 1x1 grid, it's 3. If it's a 1x2 grid, then you're extending out the dimension by 1, and the number of ways you can form an answer where the last thing in the grid on that row is a certain color is 3, so you have 2 ways of adding on to it. And then if you were extended it out some more, then again it's 2 ways here, then it's 2 ways here, 2 ways here. So I mean, if you extend out, let's say, a 1x5, 1x5 is 3 times 4 twos. 2 to the 4th is 16 times 3 is 48. So 1x5 should be 48. Sure. And now how do you do the row below that first row? It just depends on this row. Okay, so there's 3 options here. And 6 options in total for the first 2. Okay, so for the very thing below this 3, the very first 3, it has to have 2 ways here. Right, there's 2 ways here. And those 2 ways needs to break down into how many ways that first 3 combines with another 2. So again, that first 3, which I'm going to say something that is A, B, or C, combines with something that is like the not A, B, C. And more specifically, let's say the first thing is arbitrarily A, and the second thing that's not A is either B or C. So A, if that's the first row, then there's going to be 2 things that are not A. So second row starts with B or C. And if I were to break it down, if it starts with B, and B, let's break it down here. If it's A, B, then, and the second row starts with B, it has to be C. Second row starts with C, it has to be A or CB. No, not CB. C, A. Well, technically B could also be followed by an A. So again, if for the first, for A, B is the starting, there's 3 falling in the second row. But then AB is one of any possible 6. And then the second row is one of any possible 3 based on those, based on whatever that 6 was. So 6 times 3, which is 18. Okay. Now I have to think about, now I have to think about the first 3 elements. So the first 3 elements could be A, B, C, A, B, A, or A, B, A, or AB, ABC, ABA, ACB, ACB, or ACA. So that's 4, where A is the start, so A could be 1 to 12. And then if I have A, then it's AB. If it's AB, then there's 6 ways of doing the AB portion, or doing the stuff underneath the AB portion. So if it's AB, then it's again BBA, BC, CA. So under AB, there's 3 different things. And under AB, AB. AB, there's going to be, gosh, how do you know, how do you keep track of the counts? So simple seeming. And you kind of need to know the order of it. Order matters. So easy if it's one-dimensional. It's just 3 times 2 times 2 times 2 times 2 times 2 times 2. First number below it has 3 possibilities here. The number of possibilities below that is 2. Then this thing is all kind of unique. It's all kind of unique. All right, let's do a little bit of reverse engineering here. So let's say 2 by 2, 2 by 3, 2 by 4, and 2 by 5. 2 by 2, 2 by 3, 2 by 4, and 2 by 5. So 1 by 2 is 6, 2 by 2 is 18, 2 by 3 is 54, 162. It's just multiplying by 3. Is that it? Are you serious? Yeah. Yeah, multiplying by 3. That's so if it's let's say yeah, it just seems to be multiplied by 3 each time. All right, let's do 3 by if it extends downwards another level, then does that just mean that it's multiplying by 3? Yeah, if it extends downwards to another level, I'm assuming like a 2 by, I don't know, a 3 by 2, I'm assuming. Yeah, 3 by 2 is the same thing as 2 by 3, so that's going to be 18, right? and then if 2 by 3, so what am I dealing with here? So it's going to be 3, 2, 2, and then if it's a 2 by 2, you're taking this and multiplying it by like 3. Like this thing becomes, so 2 by 2 is, yeah, and so this becomes like a 3 here. And then if you extend that out, each time you extend it out, that's going to be another 3. Okay. Okay. How do you extend it out to m by n then? That works for the second row. The third row, a 2 by 3 is the same thing as a 3 by 2. So 3 by 2 should also be, well, 2 by 2 is 18, so it's 54. So if you take this thing, yeah, so this is another 3 here. And I assume that if you extend it out, then it's like 3, no, there's no, it's not going to be that easy. So 2 by 3 is like 54 here, and a 3 by 2 is like 54 here. Can't really highlight it like this shape. So it's 54 this way and 54 vertically. Then how do you tell how to waste still in a 2 by 3 to a 3 by 3? 2 by 3 to a 3 by 3. Well, only one way to tell. Reverse engineer some more. Test case 3 by 3, 3 by 2, 3 by 4, 3 by 5. 3 by 2 is 54. 246. 54 to 246. Oh no, there's a single factor there. 254, or 54 times 5 is more than that. 54 times 4 is less than that. Okay, so it's now no longer in the multiplication range. Huh. This is roughly multiplied by 4, roughly multiplied by 5. 5 times 246 is a 1224. And this is roughly 5 as well, less than 5. Okay. So if I have something that's a 2 by 3, that's 54 ways. How do I compute the third row from there? How do I compute this? How do I compute from 2 by 2 to 2 by 3 actually? Or 2 by 3, 2 by 2, which is 18, to 2 by 3. Well, that has to be the same thing as me going from 2 by 2 to 2 by 3, just by multiplying by 3. So this thing has to be multiplied by 3 here. And then And then if you extend that out, I guess you just can't. I'm missing something. I'm missing something pretty badly. Three by 2. 3 times 2. 3 times 2. So 2 by 1 versus 1 by 2. There's both 6 ways. So they're both 6 ways there and 6 ways there. Right. This thing right here, that ended up being 3. That box right there. Not quite. It's not multiplying by 3 there, actually. It's like this box right here. If I did 3 times 2 times 2, that actually ends up being 12. But then if, so this x, it's not a single factor because it then basically makes 12 into 18. In terms of like multiplying everything in the box together. Which, to be fair, is not necessarily even the way to think about it. So if it's 3, 2, 2 on the first row, and it's like 2, well, technically it'd be 2 and then 1.5 if I wanted to complete it. I wanted to actually have some factor that includes inside the box to make the box equal to the multiplication of every element in the box equal to the number of ways to make that grid. So technically here it's going from 322 is 12, and then this right now is another 6. No, this is 3. This thing would need to be another 2 here, I think. 2 times 2 times 1.5 is 6. No, this thing needs to be 9. So 2 times 1.5 is 3. This thing needs to be a 3. 3 times 2 times 2 times 2 times 1.5 times 3. So 2 times 2 is 4, times 2 is 6, no, times 2 is 8, 1.5 times 3 is, that's not even right, that's 4.5. 4.5 times 3 is 13.5. No, that's not it. So, is there a single multiplier that I can use here? The next number here, it's 1.5 here. It's 1.5 here. I'm pretty sure. Is it 1.5? I think it's 1.5. 2 times 2 is 4, times 2 is 8. Okay, so 2 times 1.5 is 3, 2 times 1.5 is 3, so 3 times 3 times 3 is 27 times 2 is 54. So 3 by 2 is 54. Yeah, 3 times 2, 2 times 3 is 54. So again, if this thing is another 2, then this is another 1.5. Yeah, I don't even know if this is any way to think about this. So let's say I have 3, 2, 2, 1.5, 2, 1.5. So I have a bunch, well, 3, 2, 2, 1.5. How many ways would extend out here? So this thing has to be 2, 1.5 here. Right. So what's the factor here? 3 to 3 by 2 is 54. 3 by 3 is 246. 246 divided by 54. 4 and 5/9. What the hell? You know you screwed up when your answer is 4 and 5/9. What the hell? 4 and 5/9. Wait. Is that right? No, 4 and 5/9 is the whole multiplication of 2 times 1.5 times this x. So 4 and 5/9 divided by 2 divided by 1.5 divided by 1.5. What is that garbage? Okay. Yeah. This is not a fruitful way of thinking about this, I don't think. But in theory, that is the number. It'd be 1.5, 1.52 approximately. So if I multiplied all those, I should get 246, I think. Let me just verify that. Well, I think so. 1.5, 3 times 4 twos, which is going to be 16 times 1.5 times 1.5 times 1.5 times 1.2. 46. Yeah, that is the magic number. Yeah, but probably not the way to actually approach it. Okay, back to the drawing board. Or back to the empty board. So you have some number of ways. If you have the number, you have the count of the number of ways to get to a certain size where the last elements of that size is a certain sequence of colors. You have the number of ways to get to a certain size where the last sequence of sizes is what? I mean, maybe you care about the last 2 colors in the sequence? maybe you care about the last two colors in the sequence because that determines what you can have for the next two colors. Interesting, interesting. So how do I get what I'm thinking into math, into some recurrence relation? So 3 and 2. So there's 3 ways and 2 ways. Now it's just going from 1 dimension to 2 dimensions is so hard. Like you can extend 1 dimension, and come up with a count. But then to come up with the count for an arbitrary second row. Wait, what? If you know that the last sequence is, if the last row is a certain number of ways, and you can determine the following row as, if it's a 1 by 2, then it's 6. And then if it's a 2 by 2, it's 3, and everything after that it's multiplied by 3. Shouldn't you somehow be able to determine the things after that? Because this row is symmetric with this row. The first thing is symmetric with the second row. So how is it not just multiplying by 3 more each time? So you have 6, you multiply by 3 to get 18. And then if it's 2 by 2, then you multiply by 3. Technically you multiply by, if it's a 1 by 3, you multiply by 3 and 3. If it's a 1 by 3, you multiply by 3. 1 by 2, 6 ways. That's 3, 3, 3, 3, 3, 3. To extend it out. It's not that easy for the next row. It's because the distribution is not equally likely. Distribution is not equally likely. I see. Okay, well I kind of get it. So I think what's confusing me is it's AB. If it's AB, So of the three, so the 6 combinations of the first 2 letters: A B, A C, B A, B C, C A, C B. 6 combinations of the first 2 letters. If I were to now go to the 2 by 2, which is 18 ways, it's A B, B A, A B, A B, B C, A B, C A. Okay, those are 3 out of the 16. And then AC, CA, AC, CB, AC, BA. Okay, so that's another set. Those are all starting with A's. Starting with B's, be BA, BC. No, whoops. BA, AB, BA, AC, BA, CB. BC, CA, BC, AB, BC, A, BC, CB, BC, AB. Okay. CA, AC, CA, BC, CA, CAAB, CA, C, no, B, A, B, C, CB, BC, CB, BA, CBA, AC. Okay. So of the 6 ways of forming the first 2, there are now each one pairs with 3. And that makes it 18. But the distribution, do I really need to go to 3 by 3 in order to make this 3 by 2? I think I might need to show this. This 3 by 2 is going to be 6. No, 3 by 2 is going to be 54. 18 times 3. Okay, I need to find a way to actually describe this. So of these 18 ways, if I choose one arbitrary way, it doesn't necessarily match that way, like ABBA, that sequence of 2 by 2 doesn't generalize to be one of all 18 sequences, in the sense that this pattern ABBA is only there in certain ones, like AC, CA, AC, where you have like 2 letters kind of alternating on the 2 by 2 box. But there could be all three letters in the 2x2. So like B, C, C, A. And those, the symmetry there is different. The groupings that are of this kind of pattern are, well, are the ones that aren't alternating with two letters, I think. So BCCA is similar to like ABBC. It's like where one diagonal is the same and the other diagonal is two different numbers. Like ACCB, BCC, CAAB. So the ones that are alternating with the same two letters are 1, 2, 3, 4, 5, 6. No, not 6. 1, 2, 1, 2, 3, 4, 5, 6. So 6 out of the 18 are alternating two colors, 12 out of the 18 are alternating, are just some other version. And then the 6 that are pure alternations of two colors, there's going to be some ways of adding onto them. And then of the others that are not alternating two colors, there's some ways of adding to them. Does that matter? When you attach a third row or third column to this, the third row or third column, it just cares about the last two of the previous row or previous column. Third row, third column. Like if I think about the third row, how many of them are A, B? So if I would have the second row, distribution of the second row, is it the same distribution as the first row? So how many ABs do I have? 1 AB, 2 AB, 3 ABs. AC, I have 1 AC, 2 AC, 3 AC. So the distribution of the third row is the same as the distribution in the first row. And then, does it at some point change? Oh my god. Okay, so if this thing becomes ABC, fuck. This thing becomes AB, A, ABC. ABA. Second row is A. Yeah, and this is to be ABC. No, second row is BAB, BAC, BC, BCB, BCB, BCA doesn't work. C A C C A B, and there has to be more. I'm missing something. B A B C C A C A C C A C A B C A C. A B A B A B B A B A B B A C B B C A A B C B C. This doesn't seem very symmetric. It can't be just 5 ways. It cannot just be 5 ways. So can't start with A. So if it starts with a B, it can either follow with an A and another B, or follow with an A and another C. Starts with a B, it could also follow with C. Can't be A, C, A, C, C, A, B. So there is 5 ways there. Okay, and then if it's A, B, it could be followed by A. No, can't start with A. But it's A, B, C, then it could be B, A, B. Can't be B, A, C. C, A, B. Can't be C, A, C. Seven? What am I missing here? Cannot be 7. So if it starts with an A, B, it can be either followed by an A or C. If it's followed by an A, then there's 5 ways to form the second row. If it's followed by a C, then there's 2 ways of forming the second row. Five plus 2 is 7. So I would imply that this be 7 times like 3, 7 times 6. This should be 9. A, B, C, B, A, B, B. What about BC? No, I already have BC. No, I have BC for this thing actually. Should be BAC, not BAB, not BAC. BCA, BCB, and then CA, B, C, C. Oof. Can't be. Can be A. Can't be another A. It's not C, so it has to be CAB. C. I've already done the B's. Oh, this is 9. This is 9. Okay. So of the 6 ways to form a 1 by 2, No, what am I saying? Of the, so this is, a 1 by 3 is 18 ways. 1 by 3 is 18 ways, of which one ABA, ABC are 2 generic ways out of 6 ways of forming, out of 6 ways that symmetrically can make those 18. 2 out of the 18 ways for a, no, 2 out of the 12 ways to form a 1 by 3. 1 by 3 is 3 times 2 times 2, so it's 12. And 2 out of the 12. It's exactly 2 out of 12. So it could also have been B, C, or, oh, sorry, AC, A, ACA, ACB. Yeah, so there's 4 ways there. And of those 4 ways, where those 4 ways start with A's, there's going to be half of them are going to be A, B, and half of them are going to be AC. Half of them are going to be A, B, and half of them AC. And of the ways that do A, B, and then some other number, some other letter, somehow the split is 5, 4. So therefore it's going to be 2 times 9 is 18, times 2 is 36. I'm never gonna solve this. Man, leave it to Leetcode to give me the weekend for these stumpers. Okay. Let's. Holy shit, it's a 58% pass. Oh shit. How am I so bad at dynamic programming? Holy cow. How am I so bad at this stuff? No 2 adjacent cells having the same color. Okay, so no 2 adjacent cells having the same color. Hmm. What if I just did a count of the number of ways where the last color is a certain color? So so let's say I fill it out. Let's say I fill it out. How many ways can I fill out the first color? So how many ways can I fill out the first color with red? 1, green, 1, blue, 1. And then how many ways can I fill out the one next to it? Well, if it's red, okay, okay, yeah. Okay, so it's gonna be a 2 by 3. It's gonna be a n by n matrix. Yeah, shit, this is so much. I've seen this problem before, to be honest, in terms of like some version of this. Okay, so it's gonna be, I need a matrix where the matrix stores the number of ways to get up to that point as the bottom left corner. The number of ways to get to that point, bottom left corner being a certain color, I think. Okay, maybe I'm jumping too far ahead. So what is this? So there's like 1, 1, 1 way. So let's say this is a 1 by 1 matrix. There's a matrix here. And the number of ways I fill out the first element of that matrix representing the number of ways I can get a 1 by 1 filled out is going to be 1 way to get filled out with red, 1 way to get filled out with green, 1 way to get filled out with blue. And then this spot, if I extend it out, the number of ways that I can end up with this thing being red is equal to the number of ways that I can have this thing be green or blue added together. So it's like 2, 2, 2. Right. And then the number of ways I can extend this thing out further, the number of ways I can get this thing to be red is the number of greens and blues here. So be 4, 4, 4. So RGB here. So the number of ways I can get green in this spot is the number of ways I get blue or red in this spot. And I think this works. So 4 plus 4 plus 4 is 12. 6, so on. And then here, the number of ways I can get a red here would be green or blue from the previous cell. So it'd be 8, 8, 8. Okay, so like that coincides with 3, 6, 12, 24. So that works for the one-dimensional case. So here, how many ways I can get this would be looking at this spot, which would be 2, 2, 2. And then the number of ways of filling this thing. It's going to be, if it's a red here, then it's the number of ways of getting green and blue, or the number of ways of getting blue and green, or the number of ways of getting yeah, I think that's actually it. So actually no, it's green plus blue, blue plus green, green plus green, or blue plus blue. So green, there's two ways of getting green here, there's two ways of getting blue here, so that means, oh shit. So that means 4, I think. So 2 times 2 is 4, and then 2 times 2 is another 4, and then 2 greens would be another 4, and then 2, so it's 16. 16, 16, 16, it's kind of symmetric. 16 times 16 times 16 is, no, that's not right, right? That's actually, is that 48? That's 48. Is 2 by, it's 2 by 2, 48. Test case, 2 by 2. I don't think it was 48, was it? Fuck. No, it should be 18. I feel like I'm pretty close. So close. So, again, this is red. The number of ways I can have this thing be red. So it's gonna be, so it ends up being, has to end up being 666, I think. But how? Or maybe I'm just not counting it right. The number of ways I can extend out to this spot. So if it ends in a red here, then maybe it's not independent. It's not like I can multiply it. Like the 2, 2, 2 represents like red, or something ending with red. So green, red, blue, red. Ending with blue would represent RG, ending with green would represent red, green, or blue, green. And ending with blue would represent red, blue, green, blue. Right? And it's the same thing here. This 2, 2, 2 is identical. Green, red. Well, I mean, it's identical but vertical. I can't do vertical, but like green followed by red, blue followed by red. So just vertical, I don't know how I'll draw it. Green, I still need to draw it somehow, to be honest. So it's like green, red, blue, red, comma, red, green, blue, green, comma, red, blue, green, blue. Okay, so if I were to consider those situations, so green, green, red. So this green followed by something. So green red is matching with green blue, or green red being the first, green being the first element. Can be followed by red or blue. And then that has to be green. That has to be this. And there's not enough green to start with. What the hell's going on with this? Two green starts, two blue starts, two red starts. I'm missing something. Green is, no, yeah, oops. Okay, yeah, two green starts. These two, green blue and green red. So it's green red and green red. Yeah, fuck. Son of a beeswax. Green, red. That's just not enough information. That's just not enough information. Interesting, interesting. Do I need to extend it out one more so that I can connect the dots in terms of matching it with the right thing? So instead of having just the counts of the things ending a certain color and in a pair of colors, so that I can pair those colors so that they match the corner color, and then I can do the next pairing. That is stupid. That would be stupidly complicated. Stupidly complicated. Okay. But would it work? So, what am I thinking? I'm thinking. I'm literally thinking keeping track of 6 things rather than 3 things. So, whether or not the last 2 is blue, green, blue, red, green, blue, green, red, within that dimension, or within that set. Would that work? The number of things that end in that spot, where the last 2 are that set. So how would that work in one dimension? So try again. So obviously somehow it's like 1, 1, 1 to start, or 1, 0, 0, or something weird to start. Maybe zeros. It's all zeros. And then maybe here, maybe you initialize it, the very first one to be ones right here. Like there's 6 different outcomes for the first 2. And then if you extend it to 3, then the number of ways you can end with, okay, so let's say, I don't like green red here, I'll do AB. So AB, AC, BA, BC, CA, CB. So if that's the corresponding endings for each of these spots, then A, the number of ways to get to AB as the third element in the sequence, one dimensional, one row, 3 columns. The number of ways to get to AB as the last thing would be the number of ways that A is the last one. A is the last one. So A is the last one would be this one and this one. So it's 1 and 1, so it's like 2. So it's like basically pretty much 2's everywhere. And that would give you 12. And then the number of ways on this one, again, it'd be A's at the last spot. The number of ways that you get to A at the last spot from the previous round, so that's 4. Is that right? 4 times 6 is 24. And so this is 6, 12, 24. Okay, so in theory that works for one dimension. And obviously this one is like similar for the second row. It's kind of like 1, 1, 1. One, 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 one. Okay, so now this part. The number of ways you can have this row that makes it a 2 by 2, where the last 2 is AB in this sequence. The last 2 is AB in this sequence. So that means that this thing has to be an A right here. So this row has to be an A. So AB. So how many ways? How to get AB? So if I think about the corner of an AB, how do I get the corner to be AB? I delete all my other previous stuff. Shit. Okay. So for 2 by 2, you're dealing with AB. God, I'm really rewriting everything again. Fuck. AB, BA. A, B, B, C, A, B, C, A. Is that right? Am I missing one? No, okay, that's right. A, C, C, A, B, C, C, B, A, C, B, A. Is that enough? I think there's not even a single AB in there. Okay, so how to get AB as the last 2 in this thing? So this thing has to end with an A here, and the things that end A here are the index 2, the third value, and the 5th value. So it has to be these 2. It's the sum of those 2. Yakuza. But then that just gives me for this row. That just gives me for this row. And then it needs to be vertical. No, actually, is it? Am I actually constructing something vertically actually right now? So this one actually represents that the vertically thing is AB. Yeah, this is AB, this is AC, this is BA, this is BC, CA, CB. Then what the hell do these things represent? Like which way is it going here? So if I have something that's going vertically here and horizontally here, then do I need another set of 6 numbers on this thing? The number of ways I go vertically a certain thing and horizontally a certain thing. In theory, it might be just symmetric. A, B, B, A. Huh. Number of ways. Six, 2 by 1, 1 by 2. 6 ways to do a 2 by 1. 6 ways to do a 1 by 2. Or 1 by 2, 2 by 1. So can you even tell how many ways that there's like an A over here or a B over here? Probably. The number of ways that you can get an A over here is equal to the number of ways you can get A as the previous element in this thing. So it's 1, 1, or 1, 1. So there's 2 ways to get an A here. And of those 2 ways to get an A here, the number of ways to get B here, well, the number of ways to get AB is obviously 1 out of 2, AC is 1 out of 2, AB is 1 out of 2, AC is 1 out of 2. What does this represent? Which direction am I going with? Which direction am I going with? 2 by 2 should end up being 2 by 2 should end up being 3, 3, 3, 3, 3. That's what it should end up being. 3 times 6. If I think about A, B, if I think about this being A, I think about this being AB, then it has to be an A here. Second row is AB. Then A needs to be in this spot. A is in this spot, then I'm dealing with BA or CA. So I'm dealing with 1 and 1. So I'm dealing with 2 things here. I'm dealing with 2 things here. So it's BA or CA. BA or CA. Those are the only 2 things that lead up to an A in this spot. If it's a BA, then it's a BA here, then if I have A, B here, A here, B here, then I know A has to be here, and I know something that's not B has to be here. Not B has to be here. So I can count the number of ways I have A in this spot. So it's 1 for BA, 1 for CA. Then for each of those ways, how many ways I can get something that's not B here. So with BA, there's 0 ways to get to something that's not. No, if it's BA here, then it can be BC here. That's fine. So there's 1 and 1. And then if it's CA, there's CA here. It's just 1 way as well. I'm screwing that up somehow. Okay, so again, this thing needs to be an A in this spot, needs to be a B in this spot. So it has to be an A here. So then this thing has to be a BA or CA. BA or CA. So B here, and this is a B here, then this could be BA here or BC here. Okay. BA here or BC here. So that's 1 times 1 plus 1 times 1. And if this was a CA, then this thing can be CA here, it can't be CB. So it's 1 times 1. What ends up 3? Ends up 3. And then what? Okay, can I extend it out to one more example? So things that end with, so here AB, things that, if this is AB, then this thing needs to be A. And the number of things that end with A here are either BA, which is 3, and that's going to be 3 times 2 plus 3 times 2. 3 times 2, so BA here, so if there's a BA here, then it could be BC or BA here, BC or BA. The number of ways this thing ends in BA and BC is 2 and 2. The number of ways this thing ends in BA here is 3. So is it supposed to be like it should be 3 times 2 plus 3 times 2, so that'd be 6. And then another one, so another 6 would be 18 here. $18 times 6 is 96. But that's not 3 by 2, is it? What is 3 by 2? What's 2 by 3? 2 by 3, 3 by 2. Should be like 54, yeah. So I had this, technically this should be 9. So how did I mess this up? So the number of ways I can end up being A, B here. This thing needs to be, this thing needs to be, well, A, B, this 3 here represents the number of ways this thing is AB, not necessarily the number of ways this thing's, although logically it should be the same. So logically it's the same. This thing being AB, does this 3 represent the number of ways this thing is ending up in 3? It's not what it is, right? This 3 represents the number of ways. Yeah, that this thing is 1, 3. This thing is 1, 3. Technically, I don't know, I can treat this as number of ways of getting this thing to be A1 is AB. 3 ways this thing is AB. And then if there's 3 ways this thing is A, B, and this thing. And then of those 3 ways, if there's a B here, no, sorry, what am I looking for? This is, so this is, has to be A, B, so this thing has to be A. So the number of ways where this is A is, this is B, and this is A, or this spot is C, and this spot is A. So for this spot being B and this spot being A, and I can kind of see what this is, this 3 here. So of those 3, or if this is B and this is A, and there's 3 ways of doing that. And there's 2 and 2. So is it 3 times 2 plus 3 times 2? That's 12. Fuck. This is B and A. And BA here, or BC here. BA and BC, there's 2 and 2. So there's a total of 4. 2 BAs, 2 BCs, 2 BA, and 2 BC. That's 4. So do I not multiply the 4 times the 2? Or 4 times the 3? The number of ways that you can get a B in this spot. Number of ways you can get all these numbers should be divisible by 3. 246 divided by 3, 82. Divided by 3, 300, 370, 1200 minus 122 is 78. 78 divided by 3 is 78 divided by 3 is 26. So 400 minus 26 is 374. The number of ways you can get. So what do these numbers represent? 3 is the number of ways you can get this to be AB. 3 is the number of ways you can get this to be BC, AB, AC, BA, BC, CA, CB. So they're all 3. So the number of ways you can get this thing to be an A is BA or CA. There's 6. 6 ways for this to be an A. And then of those 6 ways, so if there's only 6, then how can this possibly go up to 9? I guess there's 6 ways of doing this, where this thing ends with an A. And then of those 6 ways, or some factor of those 6 ways, you need to multiply by the number of ways you can get this to be something that can work with it. So there's 6 total ways this is an A. There's 6 total ways of this thing being A. Yeah. And then there's 6 total ways where you can have these two be something that produces an A here. And then of those 6 ways, how many ways can you, of those 6 ways, times those 6 ways, times those 6 ways. Times those 6 ways. 1, 2, 3, 4. Let's be applied times 1.5. This thing ends with an A. Okay, I guess I need to go back a step because I didn't fully understand something. Okay, so here, so what was I considering here? I was considering the 1s here to represent the vertical. So 1 is vertically AB, 1 is vertically AC, 1 is vertically BA, BC, CA, CB. And so the stuff that ends with a 1 here is, or that ends with an A here is going to be this 1 and this 1. There's 2 1s that end with an A. And if it's this one where it's B, then A here, B, then A here, I multiply the number of ways that it's B times A, B and A here, with so if it's a BA, it can be either BC or BA here, BC here, BA here. So I think it's 1 times 1 is 1 times 1. So that gives me two ways of getting BA here, or either of the two ways could give me another B here. So at least two. Well, yeah. And then there's one way that's CA here, and I can only do it with CB here, so it's 1 times 1, so it's 3. But then that same process for this one doesn't really work. So if it's a C, let's say this is BA, so there's 3 ways of getting BA here. And for here, there's 2 ways of getting BA, 2 ways of getting BC. Wait. So this is BA here. It could be BC here or another BA here. Yeah, I think that's actually right. So there should be 3 ways of getting BA here, and then multiply by 2 and 2. So the number of ways of getting BA through that process there is going to be 3 times 2 plus 3 times 2. So it's 8. No, 12. But then it should be symmetric. Or it should not be symmetric. So if it's something like AC here, AC here, and AC here, or AB here. No, it cannot be B here. So starting with AC, A then C, could be BA or CA, BA or CA. BA here could be BC or BA here. So 3 times 4 is 12 again. It's just too big. It should be 9. Should be 9. Oh my god. I think I am too tired to do this right now. Okay. I will hopefully make another stream to continue this again, to not lose another streak due to these stupid hard problems. Pixie, I'm from California, but my name is truly unknown. But anyways, I think I'm going to